My name is Nayef Al Omar. I'm a PhD student in computer science. I'm going to be talking about the future of software engineering. Okay, the motivation behind this is that, as we know, the software engineering or programming or application started in the early 50s. And it used to be very small, the applications were very few, but as we see in our future, it grows very fast. So the process was very simple. The process or software process was very simple at the beginning, and we can cope with it, but now we have to think about it very thoroughly. My outline is, I'm going to talk about history of software since the 50s until now and what's going to be in the future. Trends of software process research during the 90s, trends of software process research during the 2000s, challenges to software community and domain, recommendation for future research, and conclusion. These numbers or these figures talk about software. How big is software nowadays? For example, in lines of code. US military, for example, they employ over 3.5 million lines of code to manage their organization. Boeing, 6.5. As you can see, you go to the end. Google runs its site and all its services with over 2 billion lines of code. Okay? To be able to manage such huge number of lines of code or big applications, we need to have a good process, a good software process thought thoroughly. At the beginning, I will talk about the journey of software before I talk about the software process. The journey of software started in the late 40s and early 80s. Early 80s. Sorry, journey of the software process until the, no, not, sorry. Okay. It's missing a slide here, which talks about the history of applications. I don't know what happened to it. Okay. I'm going to talk about history of applications. It starts in the early 50s when they started making applications. They used to use binary code and switches, turn-on switches and things. Then late 50s and early 60s, they invented special purpose languages, which they call assembly languages, special purpose for each computer. In the early 70s, new types of software, new types of languages, networks started to appear, some databases and stuff like this. Okay? In the 80s, more high-level languages started to take place, like Pascal, C, and so on, and special purpose software like word processing and stuff like that. In the 90s, languages has changed. The concept of languages from procedural to object-oriented languages. In the 2000s,
you have 10 minutes and we need to start.
Okay. In the 2000s, more social network applications and so on. In the 2010s, more autonomous or self-driven softwares. Now I'm going to talk about the journey of software process. Late 40s and early 80s, no real software process was was there. Everybody was developing softwares on individual level, on group levels, and so on. The software process was not, software engineering was not there at that point, okay? It started late 80s and 90s with process modeling languages. They started making process modeling language, improvement of software process, making metrics and empirical studies, assessment, behavior performance of the software, unified process, personal software process. Okay, problems and challenges in the 90s. The first challenge was in the 90s for the software process and software engineering was the process was not human-centered. It was, the purpose was functional, just to the functions of the software itself. They were not taken into consideration the how this software will work with people, with organizations, and so on. And they thought in the 90s when they were doing the process, they were not borrowing from other disciplines to improve the process. They were thinking that the process for software engineering is so special. You cannot borrow from other disciplines. So no borrowing from other disciplines for the process and process improvement. The purpose of the process application tools must be redefined. They created many tools at that point, okay, in order to automate the process, the software process. Empirical studies became research exercise. Another problem, there were a lot of studies for the research process, and there was no outcome for this research. They were just an exercise, intellectual exercise. Okay. In the 2000s, the human-centered issues for the software process was taken into account. They started looking at the functional issues of the software process, which they did not pay attention to it. They did not pay much attention to modeling and process executions, automations, because they thought software, you cannot automate everything in the software, so there is no reason to look at automation and stuff like this. Realize that software process performance is framed by conduct of organization and individual rather than fixed process. The trends in the 2000s, social aspects. In the 2000s, as I mentioned, non-functional requirement, availability of technology does not always improve the performance. So we have to look at the quality technology and the interactions between humans and technology. Improvement is a result of proper interaction between individual-centered social aspects and technology. Therefore, the two elements, the social aspects and the technology, cannot be studied in isolation. They have to be studied together. Okay, and the agile software approach. Agile software approach, these are the key points for it, for valuable product in timely manner. People can change the requirements and so on. Leading agile methods, there are many methods in the 2000s, like adaptive software development, Crystal, dynamic systems, lean methods, Scrum methods. They all follow agile. The research trends in the 2000s, non-functional requirement, research in the research area, they start looking at the non-functional requirements, produce research in that area to improve the quality of the software process. Global software engineering. Since we are in the internet era, okay, now the teams, the definition of teams, the definition of development is not localized in a special area. Now it's over many places, many areas. So does agile can we apply agile in this global software engineering? Empirical software engineering. They were very successful in that area. There were many research research results that supported that. Model-driven engineering. This is an area which has been developing since the 2000 and still been developing, which means in each business model, they create special process. They create special process where it's divided into 3 levels: computational independent model, platform independent model, platform specific model. This is because each business type can have similar logic, similar functionality. So they can use that for that model, computational model. Platform model.
How many slides do you have left?
Out of time?
وبعدين لما الواحد يشرح محاضرة and when we give a lecture you start make us please يعني the number of slides is big.
لا 10 خلاص.
You are out of time. So if you have many slides, maybe it's time to go to the conclusion.
Okay. Let me go. Future software system challenges: distribution, mobility, autonomy, system of systems, networks, agents of agents, and so on. Non-stop adaptations and upgrades. Okay. Then future research. This is very important. I will mention the first point. In the research process, we should look at convergence rather than following rules. Convergence rather than following rules, because software is not rigid. Convergence instead of strict compliance with the development process. Irregularity in software, a lot of irregularity, and because it's a winner, where regularity is a loser. So we cannot be very rigid. We cannot be very rigid in that aspect. Conclusion: software have been increasingly involved in human activities over the past 3 decades. This imposes challenges on software development process. We have to have ground-breaking and new approaches. Software process research can play a fundamental role and need to continue focusing on investigation-related research disciplines. Software process research is very complex, and we have to pay attention to that. Thank you very much. And